This week's Multiple Choice Monday is about organic chemistry, in particular the electrophilic addition reactions of alkenes. And it's asking us to work backwards because it has given us the name of a product and it wants us to decide which compound reacts with hydrogen bromide to give that product. And there is also a clue in the question that talks about it being the major product. So almost all exam boards for A-level now discuss this idea that when you add a hydrogen halide like hydrogen bromide to an alkene, then there is an option about where the hydrogen adds and where the bromine adds, and we need to know what is most likely, i.e. what is going to be the major product. The first thing I would do in this question, therefore, is I just sketch out the structure of the 2-bromo 3-methyl butane. So I'm going to need 1, 2, 3, 4 carbons in my main chain, and we're told there is a bromine off the second, and there is a methyl group off the third, and then the rest is just hydrogens. Okay, so first thing I can think about, well, I need to get from an alkene to that, and I need to add HBr. So one of the main things that's going to be added is the bromine. And next to the bromine, I need to add a hydrogen. So what that means is there's actually 2 possible locations in theory where my hydrogen could be. They could be there, or could be there. Remember, it's just position along the chain. So we just need an adjacent carbon, because what I'm saying with that is that I could either start with this alkene here, so I have an H and an H, then I've got my C with my Br, which has just got an H attached, and then CH3, H, CH3, or, so that would be if we were adding across that way, or the other alternative is if I were adding that way, and so this time that would all be H's. Then there would be a space here for my bromine, a double bond would be in the middle, so it would be a but2ene with a methyl group still on that carbon and a CH3 at the end. Okay, so, and also what I'm going to do now is just turn it into structural formulae. So instead of writing that, I'm going to turn it into CH2. I'm going to turn that into CH, CH3, CH. We'll just leave that as it is. And then just to make it look more like the question, again, I could take that last carbon there and put that as a CH3. So I've got CH3, CH, C, CH3, 2. Now remember that this could be written the other way round as well. So that's one thing that I need to spot. Finally though, maybe I need to think about this major product idea. Before I think about that though, let's just see if we can actually eliminate any of the possible options. So looking at A, it's got 2 methyl groups attached to a carbon with a double bond. Okay, well I do have that in my molecule on the right hand side. So I've got CH3, CH3 attached to a C double bond, and then a CH, and then a CH3. Okay, so A is a possibility. B is not a possibility. I can immediately discount B, and the reason that I can immediately discount B is it only has 4 carbons in total, and my molecule has 5 because it is methyl butane, so it's going to have the butane and then a methyl group too. 1, 2, 3, 4, 5. There's 5 in the next one. However, what's happened there is my methyl group is on that second carbon along, and that's not either of my options. So nowhere do I have a CH3 and then a CH2 in either of the 2 possible molecules I've drawn. So it definitely also cannot be C, because that CH2 group does not exist in the middle of the chain anywhere that I've got. Okay, so it's between A and D so far. Let's look at D. I've got my 2 methyl groups, correct, with a CH, so that is that and that and that, and a CH, CH2. So okay, it's down to A and D. So we're now thinking, how do I work it out? We have to use Markovnikov's rule. You don't have to remember that name. What you have to remember is that the hydrogen adds first, so go back over electrophilic addition if you've forgotten about that. Hydrogen adds on first, so the double bond breaks up and attaches to the H, and the bromine then breaks off and adds off second. In the middle of the mechanism, one of the carbons will have a positive charge, and the positive charge will always form on the carbon that has the least hydrogens attached to it. So the hydrogen will attach to a carbon with the most hydrogens, and then a positive charge will form on the carbon with the least hydrogens. Or we can talk about carbocations and whether they're primary or secondary. So if I were to add on a hydrogen to this molecule in the top, so I'm just going to rub off that double bond, and in fact let's draw those hydrogens back out. That's how it was. I've got 2 options therefore. I can either add the hydrogen onto the left and have the positive charge there and the bromine will end up there, or it can happen the other way round and the hydrogen adds to the middle of the chain and I end up with the positive charge on the end. That would mean that I've got a choice of primary, because this carbon would be primary, it's at the end of the chain, or secondary carbocation. Now, the more carbons there are attached to the positive carbon, the more likely that positive carbon will form, the more likely the plus will be in that space, and the more likely the bromine will be in that space. So that means that it's the secondary carbocation that is more likely to form, and therefore the bromine attaching to the second carbon is the most likely product, which means that my answer is going to be D, because D was that structure. So we have 2 CH3s at the end, we have a CH, then we have another CH, and then we had a CH2. We add a H to the CH2 part, we leave a positive charge in the middle. If we looked at the other option at A, which does have the right structure and could form the 2-bromo 3-methyl version, but in order to form 2-bromo 3-methyl, what would need to happen? I just rub off that double bond, and then we have a look at our options. I can either put the hydrogen on the one on the left or the one on the right. To form the 2-bromo, what I would need is to put the H there and have the plus there. Now that is a secondary carbocation, but if I did it the other way round and put the plus here and the H on here, this is a tertiary carbocation, and tertiary is more stable than secondary. So this would be the most likely, and the most likely product if you were reacting that alkene would be 2-bromo 2-methylbutane, not 2-bromo 3-methyl. So that's why it's not A, because it does not proceed through the most stable carbocation intermediate. Okay, so my free chemistry revision club is absolutely running, and I'm also putting more revision materials up on my website. So check out my website, ckchemistry.co.uk. You can sign up for the revision club where you get weekly emails with chemistry content. And my revision masterclasses, I'm 3 classes in, and I'm actually now sold out for live participation in those classes, but you can sign up for recordings access, which gives you all the materials the practice questions, the checklists, the practice papers, and the recordings for the class, and also gives you the opportunity to ask questions. And of course, if you subscribe to my YouTube channel, you'll get new videos here every week as well.